How might Earth appear from a great distance in the cosmos? You are peering into the past as you gaze at the stars in the night sky. You did indeed hear that accurately. Anytime you observe something in the universe, you are doing so in the past. This is so that we can only see things as they were when their light was most recently emitted and when it reached our eyes and other senses. As a result, it may take millions of years for light from distant objects to reach us. Both on Earth and everywhere else in the cosmos, that is true. What about a faraway observer on a planet watching us, then, assuming that's the case? What could he possibly see? Will he be able to see people or extinct animals? Let's discuss what Earth would appear to be like today from a vast distance in the universe. How do eyes function? How do we see everything that is around us? It's fairly straightforward, therefore physics must surely be at work there. A specific item emits or reflects light, and when that light enters our eyes, we are able to see an image of that object. If there is no light shining on our eyes, we perceive darkness, which is the lack of light. Although it is the fastest thing in the world, the immense distances of our cosmos cannot be traveled at the speed of light. In fact, the size of our universe makes it impossible for anything to move through it in less than 93 billion years, even at the speed of light. Only at the moment the light that is presently approaching was emitted from the item you are watching can you see it as it was at that time. Because it took light 2.5 million years to get to us, the image of Andromeda you are viewing is 2.5 million years old. Similar to how the sun's image you saw this afternoon was not real time, but rather 8 minutes old. It's a significant insight. Unless they have spent a significant amount of time traveling at or near the speed of light, or in an exceptionally large gravitational field, such as just outside a black hole's event horizon, all observers in the universe will perceive right now as the same instant in time relative to the Big Bang, 13.8 billion years after that creation event. For nearby objects, the speed of light is rapid enough to generally overlook the lag time between source and observer. The further back in time we view, though, the nearer the Big Bang's instant we are, the farther out we look. This would imply that a faraway observer is viewing an old image of Earth, i.e., how the Earth appeared in the past, when they look at it. Let's travel to various locations in space and observe Earth from there to get a better idea of what it would look like. And let's suppose we have a telescope that is strong enough to easily observe Earth from these far-off locations. 5. From galaxy GNZ11, the furthest object from which humans are aware. GNZ11, which was first identified in 2015, is the farthest galaxy ever observed in the observable universe. It is a strongly redshifted galaxy. The galaxy was just discovered at a distance of 32 billion light-years from Earth, 13.4 billion years ago, 400 million years after the Big Bang. If you're wondering how it can be so far away from us since the universe is only 13.8 billion years old, read on. The cosmos is indeed expanding, and it is doing so faster than the speed of light. We could observe a newborn Milky Way galaxy forming if we pointed our telescope towards Earth, or at least tried to look in its general direction. Billions of stars, gases, and dust would be drawn together by the dark matter to form a brand new Milky Way. Since the solar system's development barely began 5 billion years ago, neither the Earth nor the solar system would even be here. Right now, we would be able to see a 13.4 billion year old image of the Milky Way. In comparison to today, the cosmos would still be relatively young and hot. This newly created cosmos and its stars would be dominated by hydrogen and helium, which would eventually drive the production of even heavier elements in the cores of these stars and set the stage for our formation, since we are all aware that we are literally stardust. 4. From our neighboring galaxy, the Andromeda. The closest galaxy to the Milky Way is the Andromeda Galaxy, sometimes referred to as Messier 31. It is situated 765 kiloparsecs, 765 million light-years, distant from Earth. The image of the Earth 2.5 million years old, or what our globe looked like 2.5 million years ago, will be seen if we attempt to observe Earth from the Andromeda galaxy. The Paleolithic period, when our ancestors first started using Stone Age tools, would be visible to someone from Andromeda. In addition to flames caused by heat, lightning, and volcanic eruptions, there would also be nighttime fires started by our ancestors, the earliest individuals of the genus Homo, but before Homo habilis. Our ancestors coexisted with Australopithecus for about 1 million years alone on the African continent, which was the only place where these recognizable night fires would occur. 3. From the nearby intact galaxy, the Large Magellanic Cloud. Although Andromeda is unquestionably the nearest galaxy to us, the Large Magellanic Clouds, or LMC, are the nearest intact galaxy to us. The LMC is a satellite dwarf galaxy of the Milky Way that is about 163,000 light-years away, or 50 kiloparsecs, away. It is around 32,000 light-years across and has about 10 billion stars in it. The Milky Way would appear huge and massive and occupy a significant portion of our night sky if we were located in this galaxy. The Earth would appear to an observer from this galaxy 163,000 years ago. Homo sapiens had already begun to evolve at this time. They were also joined by Neanderthals, Denisovans, and maybe the last of the Homo erectus, who are our immediate ancestors. Earth would be abundant in life-related traces, with a thriving flora and fauna. The last long-lasting ice age before the rise of human civilization would have lasted for about 80,000 years on Earth. 2. Sirius, the star that shines the brightest in the night sky. The brightest star in our night sky, Sirius, is one of the countless that make up our universe. It is a binary star system that is 8.6 light-years from Earth. Earth would look the same if we observed it from the Sirius star system as it did in 2014. 1. From the Voyager-1 probe, the farthest man-made object, as light from Earth, would take 8.6 years to reach Sirius. Officially, Voyager-1 is the farthest object built by humans. It is currently 14.7 billion miles, or 23.5 billion kilometers away from us at a distance of 158 astronomical units. After being launched in 1977, it took 45 years for it to travel to its current location, which is outside of the solar system's termination shock. It is one of just 5 spacecraft that are now evading our solar system, and until we launch a new mission to catch up with it, it will always be the farthest away. The perspective it has of Earth, however, is just 21 hours and 46 minutes old because it is so far away, further than any planet, moon, asteroid, or Kuiper Belt object in our solar system, and it sees us as we were at that time. Observers on the Moon, Jupiter, which is currently at its closest point in 59 years, and Pluto, which is currently 5.1 billion kilometers, 3.2 billion miles, away, see the Earth as it was 1.25 seconds ago, 33 minutes ago, and 4 hours and 44 minutes ago, respectively. These many perspectives on the Earth in various timelines would be obtained by looking at it from various locations in our universe. The amount of time someone looks back in the past when they look at us from anywhere in or around our solar system is relatively brief, especially on a cosmic scale. Another way to look at it is to consider how little our solar system is in contrast to 1 light year, which Voyager-1 won't cross for tens of thousands of years. The Earth as it is presently won't be visible to an advanced alien civilization if they try to view us from a distance. They wouldn't be able to witness our technological advancements till they were 200 light-years away from Earth and would only see an ancient image of it. What do you think about looking at Earth from different vantage points in the cosmos? Would you like to make an observation or embark on such a journey? Share the video with your friends and let us know what you think in the comments section down below.